So one more problem. A bar magnet of magnetic moment 1.5 joule per Tesla lies aligned with the direction of a uniform magnetic field of 0.22 Tesla. Under this, first one, what is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction and opposite to the field direction? Alright. Next, what is the torque of the magnet in both the cases? Alright. So go ahead, solve the problem. Okay, so let's see what are the given information. So first they have given the magnetic moment as 1.5 joule per Tesla. Next, the field strength to be 0.22 Tesla. Right. Now, see, the first one is, see, the initial angle between the axis and the magnetic field. So here theta 1 becomes 0 degree, right? Now the final angle between the axis and the magnetic field becomes 90 degree, correct? So you have theta 1, you have theta 2. Now let's see the work done. See, work done was mb cos theta 1 minus cos theta 2, correct? Substitute the values. So you will get 1.5 into 0.22 into cos 0 minus cos 90, right? So you'll get 0.33 joules because cos 90 is 0, cos 0 is 1, correct? Fine. Now under this, the second one, see, second one is the initial angle between the axis and the field, that is 0 degree, right? Now the final angle becomes 180 degree because it's from 0, it is going against the magnetic field till 180 degree, right? So the work required to make the magnetic moment opposite to the direction of magnetic field. Okay, again we have to use the same formula. All right, so you have mb cos theta 1 minus cos theta 2. Okay, now if you apply the formula, so m value you already know and then b value you already know, theta 1 theta 2, substitute 1.5 into 0.22 into cos 0 minus cos of 180, right? So cos 180 is negative 1 and cos 0 is 1. If you substitute, you will get 0.33 into 2, which gives you 0.66 joules. Alright. Now see, in this, the next question was you were trying to figure out the torque, correct? So in the first case, your theta 2 is 90 degree, correct? So that's basically the angle theta by which you are rotating the magnet. So tau is equal to mb sine theta. So you have 1.5 into 0.22 into sine 90. Alright. So that gives you 0.33 Newton meter. Alright. So 0.33 Newton meter. So this is for the first case. Next, for the second case, you have the angle of rotation to be 180 degree, correct? So tau is equal to mb sine 180. Sine 180 is what? 0. So there is no torque in the second case. Alright. So answer is 0 Newton meter basically. So no torque. Understood? So this is how the problem goes. At a certain location in Africa, a compass points 12 degrees west of the geographic north. The north tip of the magnetic needle of a dip circle placed in the plane of magnetic meridian points 60 degree above the horizontal. Horizontal component of the Earth's magnetic field is measured to be 0.16 Gauss. Specify the direction and magnitude of the Earth's field at the location. Okay, go ahead, pause the video, first understand the question, then you can solve. Okay, see, in the first part of the question, they've given that the angle between the geographic and the magnetic meridian, that is nothing but angle of declination. Okay, that is 12 degrees. Alright, between the west and the north. See, the next part of the sentence, see, that tells you that the magnetic meridian, in that the north is making 60 degree, right? So that's nothing but the angle of the dip. Okay, so dip is 60 degree. Next, at the last part, they have given you the horizontal component of the Earth's field, that is given to be 0.16 Gauss, correct? Right. So these are the three things which they have given it to you. right? Okay, now see, remember we had a formula BH is equal to B cos delta, the relationship between horizontal component and the dip, right? So BH is known and delta is known because that's the angle of the dip. If you apply that, you will have B is equal to BH by cos delta, right? So if you apply, you'll get 0.16 by cos of 60. So cos 60 is known, 0.16. So if you divide that, you'll get 0.32 Gauss. Okay, so 0.32 Gauss, meaning at that particular point in Africa, which is at 12 degrees from the geographic north, the magnitude of the Earth's field is 0.32 Gauss. Okay, that's all the question is telling you. Alright, so don't get scared whenever you see these kind of long and lengthy questions. Okay, let's see one more problem. See, the problem goes like this. A short bar magnet has a magnetic moment of 0.48 joule per Tesla. Give the direction and magnitude of the magnetic field produced by the magnet at a distance of 10 centimeter from the center of the magnet on two sub questions, the axis, all right, then the equatorial line normal to the bisector of the magnet. Okay, so you have axial and equatorial. All right, go ahead, pause the video, solve the question. Okay, let's see what are the given information. So first, the magnetic moment is given to be 0.48 joule per Tesla, right? See, now the distance is given to be 10 centimeter, right? That's 0.1 meter. Now, the magnetic field at some distance d or at some distance r, you can say, the formula is given by B is equal to mu naught by 4 pi 2m divided by r cube, correct? So this is the given formula. Now, if you apply the given information, so mu naught by 4 pi value is 10 power minus 7, right? So 10 power minus 7 into 2 into 0.48 divided by 0.1 cube. Okay, 0.1 cube. So here we are considering the fact that the length of the dipole is very small. All right. So if you apply the formula and if you calculate, you will get the answer as 0.96 into 10 power minus 4 Tesla. All right. Convert it into Gauss. So remember, 1 Tesla is 10 to the power of 4 Gauss. In other words, 1 Gauss is 10 to the power of minus 4 Tesla. So 0.96 into 10 power minus 4 Tesla becomes 0.96 Gauss. This is the magnitude. Now, this magnetic field is along south to north direction. Okay, this is around south to north direction. Alright. Now, the second part was the magnetic field at an equatorial point, right? So the magnetic field distance is still 10 centimeter, that's 0.1 meter, right? Now, if you apply the formula, you have B is equal to mu naught by 4 pi into m divided by r cube, right? So apply the values. You will have 10 to the power of minus 7 into 0.48 divided by 0.1 cube, right? So this gives us 0.48 Gauss. All right. Now, in this particular case, the magnetic field is from north to south. Okay, it will be from north to south. So this is how you calculate whenever any dipole questions is given.